Now for this example, I want you to notice how the directions are different than our previous example. These directions, new flashcard, say use rational exponents to write as a single radical. So we're using rational exponents. So our first step stays the same. It's to say take whatever radicals you see and rewrite them as fraction exponents. But then it's saying whatever you get in the end, after you simplify stuff down, your final answer should only have a single radical sign left. That's our actual goal of this problem. So let's take the first example, and let's rewrite each of those radicals as a fraction exponent. The square root we can rewrite as the 1/2 power. The fourth root we can rewrite as the 1/4 power. Now I have x to a power times x to a power, so I know the rule here is that I can add those powers together. And so off to the side in my scrap paper land, if I add 1/2 and 1/4 together, I need a common denominator. So I know that's going to be 2/4 plus 1/4, or 3/4. So I get x to the 3/4. But again, my directions here were to write as a single radical. So my final answer should be a radical. So I'm going to take this x to the 3/4 and say, hey, this power of 3/4, 3 is the power I'm raising to, 4 is the index. So I have an index of 4, a power of 3. And that's the answer that I'm looking for. Let's come over to this guy. This guy's a little bit trickier. Directions are still going to help us though. Because let's start off with the first part of the directions that say to use rational exponents. The cube root means the 1/3 power. The square root means the 1/2 power. Now we can't simply add these exponents together because our bases aren't the same. So that's not the rule of exponents that I can use. So instead, I really got to take a step back here for a minute and say, what was my final goal again? My final goal was to write a single radical. What part of the exponent is that referring to then? That means in the exponent, I'm looking to say I need the same denominator. In order to have a single radical, I need the same index. So I need the same denominator in both of these. So we're going to try to rewrite each of these fraction exponents with the same denominator. We're going to rewrite 1/3 as 2/6. We're going to rewrite 1/2 as 3/6. And now comes a step that we haven't done yet, even though it's perfectly legal, is we're going to take that denominator of 1/6 and we're going to apply the power over a product rule in reverse. Remember, the power over a product rule is the one that says if I have xy to the a power, then that's x to the a, y to the a. And we usually go from left to right with this rule. We usually take the a power to each. But this rule could go right to left as well. That if you have a product of two exponents that both have the same power, you could pull that power out. And that's what we're going to do here, is we're going to say 3 squared times 2 cubed. I can pull the 1/6 power out. 3 squared is 9. 2 cubed is 8. And 9 times 8 is 72. So I'm looking at the 6th root of 72. Now I have a single radical. That was my goal.